Okay. So this is improving web responsiveness from real world cases, and that brings my experience and my audits to you, so I can share what I keep finding, and hopefully you don't make the same mistakes over and over. So this is a poor interaction, right? Do you agree with me? It's users click, and after 500 milliseconds, the website is reacting. Whilst this one is a good reaction time. So nothing asynchronous is going on there, just the main thread being overloaded with stuff to do. So in 50 minutes from now, you will know how to avoid the most common mistakes that slow down the UI responsiveness, and you'll learn it from me, which I define myself as a web performance geek. I worked in web like for my entire career, which is 26 years long now, yes. Front end mostly, e-commerce, 10 years, and 5 years of web performance. You can find me with this Verlicchi, is how do I pronounce it? Verlicchi, maybe. Handle, pretty much everywhere, GitHub, etc. I work at this company, which is called SpeedKit. We have some guys here from SpeedKit. It's a tool that makes the website load instantly, preloads and pre-render. It does dynamic caching and acceleration. It has zero infrastructure changes required in your setup. And we do the plug and play. We do the integrations for you. It's plug and play. And whilst this is useful, very useful to make the loading fast, it doesn't help our customers making the interactions better. It doesn't improve. So we do the audits to help them also improve the IMP part. So what we'll cover in this talk is the 3 common errors I keep seeing, what is the cause of each slowdown, and how to avoid these slowdowns on your website. So by show of hands, how many of you have never tried to improve IMP? Wow, never, no one. Yeah, I was expecting like that. Tried but failed? Yes, I know. Robin, you always meet that, I know. And yes, you improved successfully IMP. 50%, so who's just shy and don't want to raise their hands? Thank you, okay. So the common mistakes I keep finding is the first and the most common one is the using synchronous analytics. So sending analytics beacons upon user interactions, but synchronously. The second one is a forced reflow. So most of the times it's a forced reflow, something going on in the paint part, I'd say, of the interaction. So repeatedly inducing style recalculation or layout of reflow, or having too much JavaScript, executing too much JavaScript, UI-related JavaScript all at once. And by far, this is the most common one. So let's dive into it. Synchronous analytics, the most common mistake I keep finding. So this is a representation of a website, not a real website, but I really audited a website that behaved like that, and I will show you the flame chart in a sec. So you can see the selected size is M. It's an e-commerce website, right? And when users clicked on another size, it took 1.1 seconds to just do this. And nothing asynchronous, nothing, it's not a fetch, nothing asynchronous was going on, just main thread being hogged by all of those calls. There is an L function, you can also call it the what the L function, it's a lowercase L, which you can see it's doing a lot of pushing things into the data layer, which is causing the main thread to be blocked for that long. It's very long. And what is likely happening, so this is a representation of the function, the L function. It's a select size handler. So users click, and this function is called, there is a select size that does something, also making the border bold and pushing things to tag manager. So you can help this function work better and the interaction will be faster by making this function asynchronous and call await yield to main in the middle. And I show you what yield to main is in a second, but this breaks the task into two tasks. The first is select size, so the user can see the bold applied to the new size they clicked, and the size is applied. And then in a second task, pushing things to tag managers asynchronously, because it's another task. So this yield to main is a very simple function. It does a return scheduler.yield, which is returning a promise that is resolved after the control is yielded back to the main thread. And you will have to wrap it into this if, because not every browser supports it, but Chromium browsers and Firefox, since August 2025, it also supports it. And for the rest of the browsers, which you know what it is, we just need that. But it's coming, it's coming. They are also developing that. So the fallback is to return a promise which resolves with a set timeout of 0. So meaning, yeah, do something asynchronous and then return here. So that's it. So always yield to the main thread before calling tracking functions or any other long-running function. If you have a function chunking a lot of data, then yield to the main thread from time to time. But Andrea, the synchronous tracking code is secretly hidden deep within Google Tag Manager, you might say. Yes, you can also tackle that. Slow GTM code, you have to do 3 things, basically. Audit, get access to your GTM container and check what's running in there. I take no responsibility for what you'll find here, the shock this might cause you. But yes, get access to it, because sometimes there is bad code there that needs to be optimized, and we don't have visibility. You're also developers, and you make the website best and fast, and then you put it to production and it's slow. Why? Because they add tags to it without our control. Remove what's unused, ask around, understand what's in there but it's not used anymore. Remove them if it's not the case. I worked in e-commerce 10 years and I had this problem. I asked around, what is this tag for? I don't know, it's Yandex stuff. Somebody put it there, they don't work here anymore. Is it someone looking at this data? No, so let's remove it. If you don't know who to ask, just remove it and see who complains. Trust me. That's the best way. And update the code, because there might be old code. Work has been done to improve IMP also on that side, so make sure you're using the latest version of the tags. And where is Jakob? Jakob? There. So if that is not enough, you can search for yield unless urgent, and you will find Jakob's post that explains how to improve IMP also with GTM. It's kind of hacky because it's overriding what GTM does, but it works. It can break, so beware. You have to know what you're doing, but search for it. It's a very good post. Second mistake I keep finding, inducing style recalculation. So this is another representation of a website. It's a landing page, and it has install our app. It's the best. Let's go on the top. But if I don't want to install the app, I just click the X button, right? And it takes 250 milliseconds, which is much more than I was expecting, to just slide the website. So remove the block element, shift everything up. Should be very fast, right? What was happening is that, so the pointer event goes on for 250 milliseconds, and most of the time is spent in presentation delay. Why? Because that's the answer. So I took a look at the HTML code, and it looks like this. HTML, head, body, and that's it. But there was this style element which was setting 2 custom properties, CSS properties, or CSS variables, as you want to call them, in the body. And there is a Chrome bug, which is closed, by the way, which title is custom CSS properties, blah, 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 slower style recalculation, blah, 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 as all children are affected. And the developer who replied to the thread said, we have optimization in place, But if you're adding new custom properties, blah, 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 we have to go down the slow path. So this is expected. It's not a bug. It's there. It's like that. It should be like that. If you set custom properties, there is a potential cascade of things that needs to be recalculated in the whole DOM. So what you can do first, you can not use custom properties and just use classes. If it's the case, that's not the case usually. Thank you. Because maybe you need the actual value there, and that needs to be calculated with JavaScript. So, but it's one way. So the first real solution to this is to assign custom properties to lower levels of the DOM where you actually need them. So if you set it to the body, maybe you need it in the header, so assign it to the header, and it will not propagate in the whole DOM, or in the main, or down close to where you need them. Second thing you can do is to avoid CSS properties inheritance, and you can do that by this with this line of JavaScript, I will say, to register a property with the CSS.register property with the name of the property, also with the other property, so 2 properties, and then you have syntax length and you have inherits false. So that not inherits that makes sure that if you need the custom property on the body, but you don't need it down in the DOM tree, just set it there and set it to not propagate. And you can set it out, of course, an initial value to it. The third thing that you can do, and you should do all the time, is ask yourselves, is this even needed? Why do we need a CSS property on the body to just, when I click the X button, I just do display none, right? And everything shifts up. Why do I need the variable there? So I tried to remove it, and everything was working like before. So I overridden the code, the JavaScript code that was doing it, and everything was working. And look at that. So no, you can't look, trust me, it was working like before. I tested every corner case, but the presentation delay now was down to 20 milliseconds. So if you don't need it, why do I keep it here? Yagnik. Maybe a developer said, yeah, maybe one day we need it. Let's put it there, and that's 200 milliseconds of wasted time. So set custom properties to close to where you need them, if you need them, and disable their inheritance if it's not required to read the value downstream. The third thing is to match JavaScript. I don't have much time, but I will make it in time. So this was a landing page rendered like that on a website for 2 seconds, and after 2 seconds, it was like that. Sliders initialized after 2 seconds. What was going on? 7 sliders initialized on animation frame fired at landing. So these slides are borrowed from a Jake Archibald's talk in the loop, which shows how the event loop works when it goes to execute tasks. I won't go into details there, but you can search for the video if you want details. Tasks are being executed, and then the event loop goes in circles again. But at a certain point in time, and 60 times per second, if you're running on a 60 Hz display, that's most of the displays, it goes right on the rendering path where the browser does style, layout, and paint. If you schedule some work using request animation frame, it will be executed there right before the style. And so if you have a long function, it doesn't matter if you put it there or there, it will still block the main thread for a long time. So maybe don't use request animation frame for scheduling non-animation work. That's meant for working with very fast code that it's useful for the animation that's been worked on. But 7 sliders initialized when we were just seeing 3, right, on the above the fold area. So maybe you can do something like initializing sliders only if they are in the viewport. So you can select all the sliders with my slider class. You have a function to initialize the slider and an observer that observes those, and when they are entering the viewport, you initialize the slider by checking if it's not initialized by checking if there is this class, slider initialized. Yield to main, just because you want to return control in case this runs for long. You can use maybe a better, leaner swiper, slider JavaScript, and like swiper, and add the class that was initialized. And for each entries in the intersecting server, check if it's intersecting and initialize the slider only if it's intersecting. Then unobserve it, so it's not initialized anymore, and catch every console error. So this is a way to execute only the JavaScript code that we need. Always check if you need this, because you can also do sliders without, just with CSS. That's one way to do it, which is already working today. In the future, we will have this CSS overflow module level 5 that will be allowing you to do like these sliders only with CSS, no JavaScript, interactive, and this is coming, but not still there. There is links below, so maybe then you can, when they will send you the slides, you can check the links. So run only the JavaScript code that is currently needed and delay everything else. Wrapping up, takeaways are: yield to the main thread before calling tracking functions. Before calling tracking functions, yield to the main thread. Yes, the same. But remember this. Set custom CSS properties close to where you need them. Check that request animation frames is only used for animations, and delay all the JavaScript code that is not currently needed. And keep your smartphones up. I want you feedback for one minute feedback, just a vote and a text if you want to give me feedback. Thank you.